Alrighty, in this video, what we are going to do is see how far we can get with our actual launcher. So, our launcher already updates itself, which again is a really important feature because we don't want, when we push a new launcher version, for people to have to go re-download it, copy over the DLLs and executable files in order to get the latest version. So this gives us the ability to change our launcher as we develop things without having to worry about a poor user experience. But of course, our launcher actually doesn't launch anything yet. So what we need to do is we need to build a form that will allow users to type in their username and password, validate those credentials, and then go off and fetch the latest version of the client. So we're going to need a couple things. First of all, we're going to need a form that allows the user to do that, but then we're also going to need a way to store the current version of the client that has been downloaded. So we'll need a way to, I'll just probably end up just dumping that in a JSON file next to the executable. And that'll just make that as easy as possible. And then we need to actually perform the logic of updating the client, which fortunately will be a lot easier than it was with the launcher, because we don't have to do the whole game of copying all the files over, moving them to another directory, relaunching, deleting the old files, and all that fun stuff, because obviously we're not in the client process, so we can perform the auto update feature without going all crazy. So the actual code we're going to be writing for the launcher bit is going to be pretty straightforward. I think the most complicated thing that we're about to go and do is going to be building the actual form. Because I want to take an opportunity here and do something a little bit more interesting with how we're going to go about building this. And that is, I want to use a proper view model with our form. Now, this isn't going to be straight up MVVM. If you're familiar with that term, or if you're not familiar with that term, that stands for model view model, and it's a form, it's a design pattern, sort of an architectural design pattern in the same vein as MVC, but it uses what's called a view model. And the view model is responsible for being a model of data that isn't necessarily tied to a specific layout of a form, but the data itself is bound to that form using XAML's data binding features. Now again, we're not going to go up in crazy MVVM, because in order to handle things like switching pages and handling navigation, all that fun stuff, if things get a lot more complicated, and you might want to take a look at using a framework to do that sort of stuff. But we're going to use a very simplistic form of it in order to kind of keep our logic separated between our actual form and the data behind it. Now, we are going to be placing all of our actual actionable logic inside of the form itself, the code behind of the form, but we're going to be using a view model to make things a little bit easier, to make our stuff a little bit more decoupled, so we don't have to worry about referencing a bunch of nasty controls and stuff. So we won't need to name any controls or anything like that. But we're not going to be doing any commands, we're just going to be pushing data. So again, MVVM, or using a view model in this case, because this isn't true MVVM, is just a process in which that we create a class that contains just basic straight up properties with a couple of modifications. And then we dump an instantiation of that class into our form, and then we instruct the form how to take that data and present it inside the XAML, which leaves all of our presentation logic where it should be in the XAML file, and then all of our other logic, our actionable logic, in the code behind, and then all of our data in a tertiary class that will be used to contain that data. Okay, so let's go ahead and start off with our view model itself, and then we'll bind it to our XAML window. So we'll see what I mean by binding here shortly. So what I'm going to do is I'm going to create a new class here in my launcher, and I'm just going to call this main window view model. Not a particularly inspiring name, but it gets the point across pretty well, and it gives us this nice little sorting here. Typically, you would put your view models in a different namespace, but again, since we have one form that has a view model, we're just going to dump it right there. Again, this isn't an MVVM video, but we are going to be taking advantage of some of the nicer features of that architecture. Now, it's important that when we create a view model that we implement a particular interface, and that particular interface is called I notify property changed. Now, like I said, the viewModel object is responsible for containing the data that the window will be using to present logic or present form elements, but we need what's called two-way data binding, meaning if I change data in the viewModel, I want that change to reflect in the actual view itself. So how do I do that? Well, it's not actually magic. It's a pretty straightforward process. What we're going to do is we're going to have this implement I notify property changed. Now, I notify property changed, of course, will bring in the system.component model namespace up top, and then I'm going to go ahead and implement its members. Now, I'm going to go ahead and hit no, and I'm going to delete what we have right there. The reason that popped up on my computer, and it might also pop up in your install, is that ReSharper has built-in support for understanding I notify property changed. However, I'm not going to be using the ReSharper support for it for all those people who might not have ReSharper, and to also show you guys exactly how to go about setting this up manually, because I think that's a better, it makes more sense to stuff. Makes more sense to stuff. Okay, so I notify property change brought in one event, public event, property changed event handler property changed. Not surprisingly, we must invoke this event every single time that we change a property inside of our view model. So that means every time a bit of data changes, we need to notify this event, and this event will be bound to by XAML, or by WPF specifically, and then every time it changes, it'll update the proper things that you bound it to. Okay, so let's go ahead and take a look at an example of a property that we're going to have on our view model. And then I'll show you guys how to set it up manually, and then I'll show you guys a really slick trick you can use to make it a little bit cleaner. So what we're going to do is we're going to write a property, and that property unfortunately cannot be an automatic property. The reason it can't be an automatic property is because we have to give additional functionality to the setter of that property. That being said, you could use something like PostSharp, for example, to insert additional code after compilation, but that has the same effect of what we're going to do manually. So what I'm going to do is up at the top of this class, I'm going to write a private boolean, and we're going to say can login. That's the property name that we're going to be writing, and so I'm giving it a private boolean field so we can store that data somewhere. Again, the view model is all about storing semantic data, that makes sense to the context of the model that we're working against. It's not coupled tightly to our actual view itself. So for example, the can login boolean, what I want that to do is I want it to control whether or not the username and password boxes are enabled or disabled. So you might be saying, well, if that's the end goal, why don't we have two booleans, one that says username enabled and the other one says a password enabled? Well, that would defeat the purpose of what we're doing here. What we're doing is we're taking the concept of disabling both the username and password fields and kind of codifying it into a general idea that's better expressed or more semantically expressed in the form of a single boolean that will in effect control two form elements inside of our view. And of course, by doing this here, it's not going to actually do anything yet until we wire it into our actual view and set up the bindings, but I'll show you guys how to do that later. Okay, so we've done our private boolean and we've implemented our event. So let's go ahead and write our property. Our property will be just a straight up C# property, but with some interesting logic in it. So I'm going to write a public bool can login, and I'm going to open up the curlies, and I'm going to write the getter, which is simply going to return can login. Not surprisingly, we're basically starting off with what you would typically implement as a property, if you're not using automatic properties. Where things get interesting is the setter, because again, when we set this property within code, we want it to notify WPF that the property changed, so that WPF can take that information and use it elsewhere within our bindings to modify our view in any particular way that we desire. So what should the setter look like? Well, in essence, all the setter needs to do is, first of all, set the value. So I'm going to say can login equals value. Then it needs to fire off the event. How do we fire off events? Well, we say var handler equals property changed. If handler does not equal null, then we're going to say invoke handler with the sender of this and the property changed event args of a new instantiation of property changed event args with the name can log in. And that's actually it. So we do a standard event invocation here. If you're curious as to why I aliased out the event into a local field and then checked if it was null, this has to do with race conditions. If it were in a multi-threaded situation and we perform the check for null and then invoke the event, it's possible that somewhere in between another thread might have set this to null after we checked it for null, but before we invoked it, causing a null reference exception. So that's why we pull it into a local field or a local variable. And that's it. That's really all we need to do. Now this particular property can be recognized by WPF. Actually, in fact, it could be recognized with WPF without us doing it, doing this particular song and dance with the property changed event. In fact, we don't even need to implement iNotify property changed for it to be recognized by WPF. But we do if we want changes to this property actually resulting in changes in the UI without any additional work. So we're kind of doing our work up front for our messaging, and then later down the road, it makes things a lot easier. But this is going to get really redundant and potentially error-prone while we continue on making additional properties. Again, we could turn this into something like PostSharp, where we have this code injected for us, or we could use ReSharper's built-in feature for handling iNotify property changed. Or we could do something a little clever, and that is going to be essentially what ReSharper does, and that's going to be making a nice little method, helper method on our view model that will clean up this code right here, so it's less error prone because we won't have to repeat it over and over again. And this will also take advantage of an interesting feature of C#5. Can't remember if this feature came in 5 or 4. Pretty sure it came in the 5, but I could be wrong. Anyway, so let's go ahead and write that method. Again, this method is basically going to perform this, but without having to specify the name of the property and without having to invoke the handler directly. So what I'm going to do is I'm going to say private void on property changed. Now, I'm going to go ahead and complete the method there with the curlies to make it not error out, but I'm going to do something really interesting inside of the parentheses here. What I'm going to do is I'm going to open up square brackets because I'm going to be specifying an attribute. And the attribute is going to be called caller member name. And then I'm going to specify the parameter, string property name, and then I'm going to specify a default of null. All right, so what's going on here? Well, first of all, this might be the first time any of you guys have seen an attribute being applied to a parameter, but attributes applied to a parameter work in the exact same way as attributes applied to a field or a property or a class or an assembly. Basically, you just do square brackets and you specify the property. So yes, you can have properties on parameters. Next, you'll notice that I initialize this to null. You'll notice that when we invoke onPropertyChanged, we're not actually going to satisfy this parameter with an argument. You might be thinking, well, that doesn't make any sense. It'll just be null all the time. Well, that's actually not the case. As of C# probably 5, but maybe 4, the caller member name, if added to a property, will result in the C# compiler actually putting in the name of the caller as the argument to satisfy this parameter. Meaning if I were to call this method from any of my properties, or any of my members for that matter, or methods for that matter, without any parameters, which we don't have to specify parameters because the only parameter is defaulted to null, the C# compiler will automatically fill that argument in with the name of the thing that was called it. So it makes things less error prone because I won't have to specify the string value, can log in for example, again repeating what I have up here on the actual name of the property, which reducing repetition in this sense makes things a lot more not secure, but a lot easier to change and less error prone. So now let's go ahead and finish off this method. It's pretty much going to look exactly like what we have in the can login setter. I'm going to say var handler equals property changed. Then I'm going to say if var handler does not equal null, then invoke handler passing in this as the sender, and a new instantiation of property changed event args passing in the property name as its parameter to the constructor. And that's it. So now that we have this, what we can do is completely remove this code, because it's now, by invoking this method, it'll have the exact same effect. So I can just delete all of that and just type in onPropertyChanged without specifying an argument to fulfill that parameter. So yeah, that has the exact same effect. When I change can-login, it'll invoke this method. When this method is invoked, it'll invoke the property changed handler, thus notifying WPF that it needs to update any form elements that are bound to the value of this property. So it's really cool stuff. Alrighty, so there's a couple more things that we would want to do inside of our view model. So for example, we do need a way to specify the kind of the status of what's going on. So we'll need, for example, a progress bar, for example, that will allow us to specify the time it's taking in order to download or extract the client. So we're going to do that here. I'm going to say private string status. I'm going to say private, I actually can't remember exactly what data type I want here. I think it's going to be something like a double. I'm pretty sure it's a double. Yeah, we're going to be using a double here. So I'm going to say var double %. Then we need two more bits of data, one for the username and one for the password. So I'm going to say private string username, private string password. So those are going to be used for those. So now what we have to do is write 4 more of these properties. Again, a little bit of a pain to write. If you're using ReSharper, it'll be made a little bit easier. If you're using PostSharp, it'll make things incredibly easy. But since we're using neither in this case, we're just going to go ahead and have to write this out. So just give me a minute while I go ahead and write out a bunch of redundant properties. It's really frustrating. You know, since C# 3, we've had automatic properties. You get so used to them. And then you have to write a full-on property, and it's like, did this really used to be what you had to do back in C# 2 and 1? Those were dark, dark days. All right, so we want our status, get return status. I almost said status. Set status equals value, and then we're going to specify on property changed, passing in no argument to fulfill that parameter, because again, the C# compiler will insert the string literal status into this method invocation. Next up, public double % get return % set % equals value on property change, specifying nothing. Public string username get return username set username equals value on property changed. Now I'm really tempted to name something in this code base Baratheon. Well, then we might get sued by HBO, but whatever. All right. That was a bit of pain to type. All these properties are a bit of pain to type because the way I have my my code formatting. By the way, you might be interested to know, I'm going to actually redo the setter, and I'm going to show you guys if you're also struggling with ReSharper's automatic code formatting when you're writing up properties like these. I'll give you a tip on how to handle that. So when I open up set, you'll notice that it tries to do this really weird, bizarre formatting, which is obviously in an inconsistent state that I don't like. Whenever like ReSharper tries to do some weird formatting that you don't like, then all you gotta do is not type in anything and hit Control-Z. And that'll get you up here. So now I can jump into my setter, and now you see everything looks good. Looks good for now, but watch what happens when I type in password equals value. The second I type in that semi, it will automatically format it in this way. which is also unacceptable for my purposes, because I would prefer it to be a full-on block and not inline as it is shown right here. Again, to fix that, we hit Control Z one time, come back up here with our cursor, and then type in onProperty changed again. So really straightforward way to kind of fight the auto-formatting. The auto-formatting usually doesn't bother me, but it does sometimes in properties. But since I rarely write properties, it's usually not noticeable. So anyway, just a quick tip on that. We certainly saved a whole lot of code by turning this into a method, as you can see. And it looks like our view model is pretty much complete. Again, right now it's really just a bag of data. If you're interested in MVVM, you can actually put in logic into your view models, although that's going to be a little bit more complex and most certainly out of the scope of what we're doing. However, since this usage of a view model significantly improves the cleanliness of our code without too much overhead, I included that bit in here instead of just using a full-on code behind with X names. All right, so now that we've done that, we need to learn a little bit about how we can actually consume this class. So if we jump into our main window XAML, let's see, we have our thing right here. What's interesting about XAML is that pretty much every attribute can be data bound. And again, data binding is all about binding a particular form control attribute, such as if it's visible, what color it is, what value it is, what text is in it, blah, 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 to an object. And the object can be of any type, and XAML will figure out how to do that binding for us. It's very easy to do. In fact, what I can do here is instead of specifying a literal for my label, I can just go ahead and clear all of that out. And I could say something like content equals. Then if I open up curlies inside of this and hit Control Space, you'll see a bunch of these cool things we can put in here. We can actually put things into these strings that aren't really string literals, but perform some levels of logic against our properties. The one that we're most concerned about, of course, is going to be the binding. Now the binding, once we do that, I can simply say binding username, which will bind the content of this label to the username. But you might be curious, where does this come from? What exactly are we binding to? Where is that string coming from? How does this grid label know what it needs to do? The answer to that is the data context. Now, data context is a hierarchical concept, meaning my label can have its own data context, my grid can have its own data context, and so can my window. And it also cascades, meaning I can set a data context to my window and have it cascade all the way down to label. Or I can override the data context just for my label and have everything else be the data context of the window. The data context answers the question, where does the data come from? Because it essentially is just an object. In fact, the type of the property called data context is object. So you can stuff anything you want into it, including your own custom view models. And that's exactly what we're going to do. In the code behind, in a moment here, I'm going to set the data context to an instantiation of our view model. And I'm going to do it in such a way that we'll have strongly typed access to our view model, as well as we're going to bind WPF to it. Once we set the data context of our window to our instantiation of our view model, what will happen is, since we're not overriding the data context on either the grid or the label, this binding will result in this label's content being bound to that value, the corresponding property on the data context that I instantiate. So let's go ahead and take a look at that. I'm going to exit a full screen here, and I'm going to jump. By the way, we will be nuking this label here shortly. This label was just for demonstration purposes earlier, and I'm just hijacking it for a moment to show a simple case of data binding, but we'll nuke it shortly and build our actual form once we get an idea about how we want to do data binding. Let's go ahead and open up our XAML, jump into our code behind. And first of all, this really irritates me. It's like, why are there so many using statements up top? One of the most important things I think people could learn or should learn about the .NET framework is where different types come from, knowing what namespace they come from, or installing a tool such as ReSharper so you don't need to remember where those classes come from. And that's because all these using statements really irritate me, because none of them are being used except for Windows and Link. In fact, Windows won't even be used in a moment here. So let's go ahead and clean up this code behind real fast so it irritates me just slightly less. I'm going to go ahead and hit Alt-Enter to remove all of those darkened gray using statements that aren't being used. I'm going to do that again here in a moment because there's another bit of code that we don't need. Actually, there's 2 bits of code that we don't need. Why? Just why? Interaction logic for main window.xaml. Well, duh. I'm not going to waste lines of code on comments that mean literally exactly what the next line indicates. It's just a thing that irritates me. Anyway, so we got rid of that useless comment. If you wanted to make it less useless and leave it in there, that's cool too. And then we have this bit right here. You'll see that main window inherits from window. It's actually redundant, funny enough. The reason why it's redundant is, you'll notice here, this is a partial class, meaning the other half of this class exists elsewhere in the project. Funny enough, you can actually find that other half anywhere in this project because it's compiled at compilation time by the C# compiler. C# compiler takes this XAML file and turns it into an actual C# class. So when we have this public partial class main window, it's actually the other half of the class is going to be generated at compile time. And it already does inherit from window. When you have a partial class, you don't need to redundantly specify what class it inherits from. Meaning, I can simply remove this qualifier right there and make the code a little bit cleaner. You'll also notice that this now allows us to remove this using statement up top. It very well might come back in the future while we're working on stuff, but for now it's not needed, and I'm not going to add any more code to this than necessary. So now we have the bare minimum of what we need to do to work with our code behind. So now what we have to do is instantiate our data context and watch it be bound to something in our XAML file. So how do we do that? Well, the easy way to do that is just to say data context equals new something, right? So data context is a property, and as you see, it is of type object, and it is on the window class itself. In fact, it's on every single class in WPF that can be turned into a control. And then we can assign it to a new whatever we want, since it's of type object. But you'll notice that doesn't really help us at all with our interaction logic, because we also need a strongly typed reference to our view model in order to do things like, well, I don't know, actually change the username to something in the future, or rather change whether or not you can log in or update the status or retrieve the values such as username and password. So to prevent us from having to repeatedly over and over again cast our data context property, I'm actually going to store the reference to our view model in 2 places. One's obviously going to be the data context because we need that in order for WPF to pick up on that data, but another one's going to be a local field, or sorry, private field on our code behind itself. And they're both going to be set to the instantiation of the same object. So what I'm going to do here is I'm going to say private, that's not how you spell private, there we go, main window view model underscore view model. And then in this line, what I'm going to say is I'm going to say data context equals view model equals new main window view model. So now not only have we supplied a view model to XAML for data binding purposes, but we've also aliased it out into a field that's strongly typed so we can access those properties later. Okay, so let's go ahead and run this, but before we do, I'm going to go into my build info, and I'm going to set the build number to something big. The reason I'm doing this is when I launch this application, I don't want it to auto-update itself, because it'll auto-update to a version that's technically deployed on my development machine, but is also actually an older version of what I have here. So I'm just going to set this to a ridiculously high number to prevent our launcher from auto-updating. Now close that out, and we have bind equals username, that's all good. Let's hit F5 and watch the magic. Funny enough, we're actually not going to see anything because we'd never set the username to anything, but I just want to show you guys at least it doesn't crash. See, it doesn't crash, but we see nothing. Why do we see nothing? Well, again, we haven't assigned the username value to anything, so it's not surprising that if we were to bind to nothing that we see nothing. So let's close this out, jump back into our CS, our code behind. After we instantiate our view model, remember this has to be after we instantiate our view model, not before, otherwise we'll get a null reference exception. I'm going to say view model dot username equals data binding is awesome. Now I'm going to hit F5. And look at that. So we now have an example. Technically, this is two-way data bound, meaning if I were to change the username to something else later, WPF would pick up on that. But this is an example of, single, one-way data binding, because we're just going from our data to our view. But yeah. That's an example of setting up our view model and setting up a basic scheme of data binding. In the next video, we're going to take a look at actually taking our view model with our can login status % username and password, creating our view for it with our progress bars, our buttons, and our text fields, and setting up the binding between the two. So we'll actually have some interaction going. So we'll see you guys in the next video.